So let's see its principles. It says that we should depend on abstractions and not on concrete classes, and we should define a factory class to create the objects by its type, and we should let the main implementation class decide which object to be created. So we are going to see these principles while solving this scenario, which is like we have to develop a meal app which supports various types of meals that can be ordered, and the meal types should be decoupled with the implementation of the meal order component. So let's see some code for this. Um, Suppose if I have various concrete meal type classes such as veg meal, chicken meal, or special meal, and each of these concrete classes have a few common data members like name of the meal, starters, meal course, dessert, and few of the common methods such as prepare with its own implementation specific to veg meal, box in implementation specific to veg meal, similarly dispatch. Then in other meal type classes also it's the same, only the implementation differs based on the meal type. So now if I go by a non-factory implementation, what I'll have to do is based on the input type of user, that which meal he wants to order, I'm going to pass that type to this order meal, and based on the type I'm going to, using if else if and all, I'm going to create the object of the concrete class of specific meal type such as veg meal, and then I'm going to call the methods prepare, box, and dispatch. Similarly, if the meal type is chicken meal, then in else if I'm going to compare. If it is chicken meal, then I'm going to do the same, create an object of chicken meal concrete class and call these methods. Similarly for special meal. So it's gonna work. Let me run this. So it asks for the meal type. I say veg meal, and it's going to uh, create this veg meal object, and it's going to call this prepare method, and it's going to print this prepare veg meal, and then similarly for box also this implementation will be printed. Now the drawback here is that suppose in future if I add one more meal type, um, apart from adding one more concrete class for that specific new meal type, I'll have to touch this implementation and add one more else if, compare the meal type, and then call the method. So it's this is not right because we are tightly uh, coupling the meal types and its implementation with my order component implementation, right? So let's revisit what factory design pattern says. So it says the first point, we should depend on the abstractions, not the concrete classes. So let's try to see that. I'm going to create a abstract class called meal, and I'm going to define here those common data members I'm going to declare here, and also I'm going to declare these common abstract methods also, and my each specific meal type class, concrete class, I will make it extends this my meal abstract class. Similarly, I'm going to do it for other concrete classes as well. And then let me do it for third type of meal also, then see. So we have done that. Now it says okay, now I have an abstract class and I have different concrete classes also. Now as it says, we should depend on the abstractions, not the concrete classes, was the first principle. And so let's see if I have to implement it using factory design pattern. Now how I'm going to do this. So here in this factory implementation for ordering the meal, I'm going to mention here my abstract class, not the concrete class. And then I'm going the principal also said we should have a factory of through which we should get the specific implementation of the abstract class based on the type. So here what I'm going to do is I'm going to create a meal factory. Let me uncomment this. Okay, so here, just give me a second. Okay, so here it's my factory class, and here based on the type of the meal, I'm going to return the concrete implementation of my meal abstract class. So if the type is veg meal, I'm going to return the object of veg meal. If it is chicken meal, then chicken meal or special meal. So it's my meal factory class. And then from my order implementation class, I'm going to call this factory, and I'm going to ask for a concrete implementation of meal based on the type. And then on this I'm going to call the prepare, box and dispatch methods. So in a way, now see, if I have to add one more meal type, then I'll simply create a concrete implementation of my new meal type, and by extending the meal abstract class, and in my factory method I'm going to add one more case for that new meal type. My main implementation of order implementation class won't change at all. Okay, so now let's try to run this and see whether the result is same. So it's gonna ask for meal type. Again I say veg meal, and it's going to print it. Because so simple, this meal is now this reference is pointing to the veg meal implementation which I have got from this factory class. So this is the basic theme of factory design pattern. If you remember these principles, that whenever you see that there can be an abstract class, and the implementations, the concrete implementers of that abstract class do the same type of things but in their own way, and you have to refer those concrete implementations from some other component, then always follow the factory design pattern. It will let you maintain a loose coupling between the different implementers of the abstract class, and the component which is your main component which makes use of those concrete classes. And yeah, you'll have to make no code change to your main implementation, main uh, component. You have to just add a new uh, type of concrete implementation, and you have to just go to your factory class and add it there. So thanks friends, that was about factory design pattern. Hope you got the basic theme of factory design pattern and when you should use it. Thanks a lot.